exponential growth and decay today. Okay, so exponential growth occurs when a quality exponentially increases over time. So here's the formula. We have a capital A is equal to a lowercase a times 1 plus r to the t. The lowercase a is your starting amount. The r is the rate. And the t is the time. We have both a lowercase a and a capital A here. The capital A is your ending amount. Did you say you remember doing it?
Yeah.
Okay, so the original value of investment is $1,800, but the value has increased by 7% each year. Write an exponential function to model the situation, then find the value of the investment after 15 years. So we're going to use this formula. There is a word in here that tells us that it is exponential growth. What is the word in there? Because on your homework, they're going to all be mixed together. Word in there that tells you when it's growth. Increase. Okay, so 1,800 is which of these letters?
A, big A.
The ending amount or the starting amount?
Ending. That's actually a starting amount.
It's the starting amount. So it's 1,800 is a little lowercase a. And then what is our rate?
7%.
Okay, so I want to write that as a decimal. What is 7% as a decimal?
0.07.
And we do not know what, oh, we do know what our t is. What is our t? 15. So 7%, just 7%, if we had a decimal, where would the decimal go on the 7%? We assume it's where? Right after the 7. That's right. So it would be right, I got to write on this board, so it would be right here. If there's nothing there, it's assumed to be right there. So percent, remember, is per 100. Means you're moving over 2 places to the left. So it would be 1, 2 places to the left there. Okay, so how would we solve this? How would we find A? We want to find our value after 15 years. Okay, so what is 1 plus 0.07? Yep, 1.07. How would we solve that? That's right. And we're going to round on this one. Our answer is going to be what units? It's going to be money, right? Our answer is going to be money. 4966. So where do we round since it's money? The nearest cent. So the nearest hundred. So 4966.2. What comes after the 2? 6. Good. You have to round that up. So I do not have enough of those blue calculators, so some of you are going to need to get one if that's only what you use, because I don't have enough for everyone. So you may need to go think to those of you to have your own calculator. Fantastic. Some of the rest of you may need to get one if you want to make sure you have one for the test. Okay, so we have a word multiply. multiplier. Try it, please. We have a word multiplier that's going to be on your homework. You're going to be asked what the multiplier is. So the multiplier is your base of that exponential equation. So your multiplier is on this one, 1.07. So how does this get bigger? What makes this keep increasing? What part of this equation makes this keep getting bigger? We're multiplying, and this number here, this 1 is greater than 1. 1.07 is greater than 1, which makes it keep getting bigger and bigger. Not a lot bigger than 1, but it is bigger. Okay, next question. CJ's Nana loves him very much. She puts $2,000 into a savings account that grows 6% per year. She told CJ he can't take it out until it reaches $3,600. When can CJ spend Sweet Nana's cash? What part here tells us that it's growing? What word? So then we're going to use our A times 1 plus R to the T. And so what's the 2,000? What part of this equation is the 2,000?
Isn't that the smaller?
So little a. What is the R? The same group. What is our rate?
I said the last one.
0.06. So 0.06. And then do we know our T in this one? No, that's what we want to find. So what is our capital A, our ending amount? 3,600. Does that make sense? Okay, so to solve this, I'm going to just go ahead and simplify it. 3,600 equals 2,000 times 1.06 to the T. What would we do first to solve and find T? We're going to do something with that 2,000, you're right.
Multiply by 1.06. No,
I heard a subtract, I heard a multiply, I heard a divide. What do you think? We want to get it off of this side, this 2,000. So we're going to divide by 2,000. We're going to divide both sides by 2,000. Does that make sense? So 3,600 divided by 2,000 is 1.8. And then what would we do next? Say hand, please. What would we do next to solve this?
You said no. I don't. Okay. Thank you. Your hair was. Oh, sorry.
Can you say that aloud? We want to do a log on both sides because that enables us to get to that exponent. That's why we have logs. So the log of 1.8 equals the log of 1.06 to the T, because once we take the log of both sides, what can we do with that T?
Well, then the T would be by itself, because if you divide by
No? What are we doing with the T?
Move the T down now.
We're moving it in front. That's right. So T times log of 1.06 equals log of 1.8. And then this group back at there in the left back, what would we do next to solve it? Good. So we're going to round to the nearest tenth on this. And if it's to the nearest tenth, it would be 10.1. And what are the units on that?
Years.
Years. So here it says it's growing per year. Okay, on to the next ones, which are decay, exponential decay. We'll see if we can still write that down. Oops. Okay, so exponential decay occurs when a quantity exponentially decreases over time. So here's the formula. And what's different about that formula from the last one? What's different? Subtraction this time. So because it's decaying, we're subtracting. So our A again is the starting amount. The R is the rate. The T is the time. The capital A again is your ending amount. So using this formula, what tells us here that it is a decay problem? Because once again, when you have your homework, they're all going to be mixed together. What word in there tells us it's a decay problem? That's right, losing. So 12,000 is what part of that? The starting or the ending? Starting, yep, 12,000. And what is, I'm going to change this 4 to 4.5%. What would 4.5% be as a decimal? You have something like that in your homework, so I'll make sure you know what to do if there's a decimal there.
Yes.
0.045. So again, we still move it 2 places to the left, 1, 2 to the left. And then what is our T in this one? 9. And then we want to find our A. So we're just going to take this and put it in the calculator. So it gives us 7928.88. So our multiplier in this one, what would our multiplier be? So our multiplier is going to be what's here in the base of that exponential part. And so that if I take 1 minus 0.045, it's 0.955. So our multiplier is 0.955. So because it is less than 1, that's what makes it get smaller every time. Okay. So you will have questions on your homework where it asks you for that multiplier. Last one, Caitlin got a beautiful Gucci bag for an early graduation present worth $12,500. She used it so much, it depreciated 6% a year. She decides she will sell it when it is still worth $8,000. How long could she keep her lovely bag? Growth or decay? Is this one growth or decay? What word tells us?
Depreciates.
Yes. Growth or decay. So 12,500 is what part?
Starting price.
Yep, starting price 12,500. What is R equal to? Let's see. Here. What would that be as a decimal? 0.6 or 0.06? 0.6. That's right. 2 places. 0.06. Does that make sense? Always 2 places over. And then that T we don't know in this one, but we do have an ending amount, which is what? 8,000. So we get 8,000 equals 12,500 times 0.94 to the T. What's our first step? We want to divide each side by the 12,500. Gives us 0.64 equals 0.94 to the T. And then what do we do next? Oh, I'll take the log of both sides. And then we move our T to the front. P times the log of 0.94 equals the log of 0.64. And our last step, here in this group, what would our last step be? That's right. And we get 7.2 years on this one.